So today I would like to discuss about the this is in the last class because of technical problem I'm not able to conclude the Kirchoffs first law. Today I would like to conclude the Kirchoffs first law. So conclusion is like this: as I considered some data. So I1 10 ampere, I2 10, I3 10 ampere, I5 10 ampere. So you see that there are 5 branches are there. Among the 5 branches, that is in some branch 10 ampere of current is what it is that it is coming toward the junction. Whereas in 2 branches 15 ampere of current is leaving from the junction. So as for the sign convention, if you substitute that, if you consider the first branch, in this branch current is coming toward the junction, therefore it is taken to be positive. Whereas the second branch current is leaving from the junction, it is taken to be negative. Whereas in this third branch current is coming toward the junction because this represents the direction of flow of current toward the junction. Similarly, in the fourth branch, current is leaving from the junction, so arrowhead represents the what away from the junction. Fifth branch, current is coming toward the junction. So, for the convincing point of view, as I consider that I1, I2, I3 value as a given, I mean that I1, I2, I3, I4, I5 values as a given. So these values, if you substitute in this expression, I mean that that is according to sign convention. You have to in this branch current is coming toward the junction. Therefore, according to the sign convention, any current coming toward the junction is taken to be positive, whereas the current is leaving from the junction is taken to be negative. So in this branch, current is coming toward the junction is taken to be positive. Whereas the second branch, current is leaving from the junction, it is taken to be negative. Third branch, current is coming toward the junction, it is taken to be positive. Fourth branch, current is leaving from the junction, it is taken to be negative. In the fifth branch, current is coming toward the junction, is taken to be what? Positive. So in this way, as per the sign convention, we got an expression where what we done here. So just add up the you are summed up the currents. You are sum of the current. So sum of the current as per the sign convention, which is equal to 0. This is what up to this extent algebraic sum of current is equal to 0. Right hand side 0. Now you take that positive current one side, negative current on the other side. So this is negative, therefore on taking to that side, so sign will going to changes. Ultimately I will get I1 plus I3 plus I5, which is equal to I2 plus I4. Now as for that, as a data given that I1 is equal to how much, I2 is equal to how much, I1 is 10 ampere, I2 is 15, like this, all these values as I substituted in this expression. So you will get that left hand side which is equal to 30 ohm, 30 amperes, right hand side is also 30 minus 30 which is equal to 0. So from this what we concluded that at this junction current is not accumulating, charge is not accumulating, charge is not conserved, charge is not storage at the junction. So therefore Kirchoffs first law, it is also referred, as I said, that it is the significance of the Kirchoffs first law is conservation of charge principle. So in the examination you will go to ask, the question tag will be like this. state and explain the Kirchoffs first law. If it is the case, so what you have to cover that? First of all, you have to write the statement. So statement can be generated with the help of mathematical expression that is summation of I is equal to 0, right? So according to that in an electrical network, the algebraic sum of currents meeting at a junction is equal to 0. So that means that in a given time, how much current is coming toward the junction, the same amount of current is leaving from the junction. Say for example, 30 ampere of current is coming toward the junction. In the same time, 30 ampere of current is leaving from the junction. So that means that at the junction, no current, no charge is accumulating. Is it? So therefore, in other words, we can say that this equation, I mean that sum of current coming towards the junction is equal to sum of the current leaving from the junction. So alternate statement also nowadays it is in a fashion. So some students are going to write that algebraic sum of, I mean that sum of current coming toward the junction is taken, sum of the current coming toward the junction is equal to sum of the current leaving from the junction. So that means that this is also correct statement. You can state that sum of the current coming toward the junction which is equal to sum of the current leaving from the junction. This is also an alternate statement of the Kirchoffs first law. Either you can write this statement or else you can write that just as I said it, this statement also okay. So basically what point you have to cover here, as I said that we are come across that some important terminology here. So network and junction and node etc. So in order to know the Kirchoffs first law and second law, so you have to encounter some important terminology in this bit. Therefore, so you have to know that you have to familiar with this terminology. Let us see. As I said it, you might know that see. So this is you know that Kurla, it is in a railway station, you see. So earlier it was in a railway station. Later on it is converted into junction. So same station, why it is converted into junction? Because so where the Kurla station, more than 3 railway tracks they are meeting, is it? So junction is a point where the more than 3 or more conductors, if they are meet at a particular point, that point is referred as the junction. What is a junction? Junction is a point where 3 or more conductors meet in an electrical network. That point we are calling that point we are referring that junction. Junction sometimes it is also known as it is also called as the node law. So that's why this law of Kirchoffs first law, as I said it is called as the junction law. Sometimes it is also called as the node law. So since we are dealing in this circuit, the current, so therefore it is known as the Kirchoffs first law. Kirchoffs first law is nothing but the current law. So these are the alternate names to the Kirchoffs first law. So far we have discussed that what is the statement of the Kirchoffs first law, is it? So what is the explanation of the Kirchoffs first law and sign convention and we are considered an illustration where we are considered 5 conductors they are meeting at a point A, is it? So each conductor possesses some definite amount of resistance, is it? Say that in every conductor some amount of current coming toward the junction and some amount of current is leaving from the junction. As for the arrowhead, you have to decide that whether the current is coming toward the junction or leaving from the junction. So according to the sign convention, you have to assess your sum of the current, sum of current which is equal to 0, or separating the variables, that is sum of current coming toward the junction is equal to sum of current leaving from the junction in the same time. Say that in 1 second 30 ampere of current is coming toward the junction, in the same second, same amount, in the same time same amount of current, I mean the 30 ampere of current is leaving from the junction. So that means that, so at the junction no charge, no current is accumulating. So therefore significance of Kirchoffs first law is conservation of charge. So these are the points you have to supposed to cover in the Kirchoffs first law, whereas the Kirchoffs second law concerned. So you can, first of all, you can write it is Kirchoffs second law, write it the statement of the Kirchoffs second law. So this is a traditional method, or you can, different approaches are there. So I feel that whichever you can easily follow it, so that I can cover that. See Kirchoff second law. So second law is also known as the voltage law. So Kirchoff second law is also called as the voltage law. So it is, instead of calling that junction, we are calling that mesh law. Mesh law. So these are the alternate names, whereas this is a loop law. These are the what. So voltage law is nothing but the Kirchoff second law. Mesh law is nothing but the Kirchoff second law. Loop law is also, we are calling that Kirchoff second law. Let us see what is the statement, how to design the statement of the voltage law. Basically, I would like to give a hint to design the statement of the Kirchoff second law. The second law, it tells about the discuss about the voltage. In a loop of electrical network, the voltage produced across the circuit element is equal to 0. This is the one form of the what voltage law. This is not routine, I mean that routine statement. So usual statement of this law is that like this. Let us see, would like to discuss so here